Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, how are you today? Today we will talking about summation notation with the sigma notation by me, by Miss Rara. So without further ado, so let's jump. What is the summation notation? Okay. Often, mathematical formula require the addition of many variables. Summation or sigma notation is a convenient and simple form of shorthand used to give a concise expression for a sum of value of variable. So in definition, we know that we have a sequence already. So when sequence, we want to adding they change the name to be a series. Okay, from the series A1 plus A2 plus A3 plus dot until En, this expression can make shorthand with the sum notation where E and N element of natural number. So in here we have the E, we have the N, we have the general term. So from here, I have official statement E index of summation. So the variable, this is this example of the variable E, but but the for the another question maybe they you can any alphabet. And then 1 is starting point of the lower limit of summation. But guys, for this question, they unlimited point. They can put the 100, they can put 1000. It's up to you. This is just the example. And stopping point, upper limit of summation. And the general of term E, typical element. So general of term, this is many things, many of general. So this is just example I said. So without further ado, so let's jump to the example. Evaluate the following summation sigma E equal 1 until 5 E squared. So from here that starting the index is 1. So we can change the E to be 1 until 5. So the 1 is 1 square plus 2 square plus 3 square plus 4 square plus 5 square, everyone. So from here we can calculate them to get the result. 1 plus 4 plus 9 plus 16 plus 25. 25, 25, 50. So this one is 55. So remember, if they are starting with the what they point starting, so you start with the point and then until what's the limit, what's the upper limit. Okay, so evaluate the following summation sigma notation E equal to until 7 with the general to E minus 1. Okay, we have to E minus 1 and then there are starting index is 2. So you change the E to be 2. 2 times 2 minus 1 until the E until 7, everyone. So we can write 2 times 3 minus 1 plus 2 times 4 minus 1 plus 2 times 5 minus 1 plus 2 times 6 minus 1 plus 2 times 7 minus 1, everyone. So from here we can write to be, we can simplify, 4 minus 1, 3, 6 minus 1, 5, 7, 9, 11, 13, right? 13, 20, 20, 40. So this one is result 48, everyone. So remember, like I said before, what the starting point, you should start with the starting point, of course, and then the limit until 7, everyone. Evaluate the following summation sigma notation J equal 3 over 5 until 5 J minus 1 over J plus 1. So from here we have the starting point is 3 and then the limit point is until 5. So from here we just need to substitute them to this general. So 3 minus 1 over 3 plus 1 plus 4 minus 1 over 4 plus 1 plus 5 minus 1 over 5 plus 1, everyone. So from here we get we make simplify to be 2 over 4 plus 3 over 5 plus 4 over 6, everyone. So we make the same denominator to be 60. 30 plus 12, 36 plus 60, 10, 40. So this one is equal 106 over 60, or the simple is 23 over 30, everyone. So this is the result of following the summation. So remember again, when they told us about following the summation, you must see the limit between the upper and then the lower, and then you need to know what's in here, everyone. Okay, that's it for this example. Write the following using sigma notation. So in here we have the series 1 plus 3 plus 5 plus 7 plus 9 plus 11, right? So in here we know that, and we already learned about the arithmetic sequence, general term of arithmetic sequence, or general term of geometric sequence. So from this example, if you know the series, they are arithmetic sequence, so that the meaning you can find the general term with the arithmetic sequence. But if they are not either not either ES or GS, so you need to find by manually. So from here we know that they have difference already same, right? They are already same equal to. So from here we know that the sigma notation is sigma, it's equal E, and then starting point E1, I mean until N, and then the general term. So from here we know that we have the En is equal 11, right? So we know the general term for the arithmetic sequence is the first term plus N minus 1 times D. Okay, the first term we have the 1 plus N minus D, N minus 1. Because we don't know what the N, we just put the N minus 1 times the difference 2. So from here, we simplify to be 2n minus 1. So we have En equal to n minus 1. So we need to substitute E starting, because we have the first term until how many terms that they have? 1, 2, 3, 4, 5, 6. They have 6 terms, and then they have E. E is 2 because we are using symbol E. So 2E minus 1. So this is the sigma notation, everyone. Write the following using sigma notation. So like I said before in the previous video, you can find this one with the using general term if they are arithmetic sequence or they are geometric sequence. But if you cannot, if they are not the both of them, so you can using manually way. So from here, they have the difference is 3 over 4 minus 1 is equal to minus 1 over 4. This one. How about this one? 5 over 9 minus 3 over 4, is it equal 28? 9, oh no, sorry, this is 36. 9, 4, 20 minus 9, 27. This is minus 7 over 36. Okay, so this is not the arithmetics. How about this is not arithmetic. How about geometry? You need to find the ratio. Ratio 3 over 4 over 1. Is it equal with 5 over 9 over 3 over 4? This one is 3 over 4. Equal with 20 over 27. Okay, so this is not the geometric sequence. So you can using manual way. So from here we have 1 plus 3 over 4 plus 5 over 9. So they have different 1, but in here they have different 4. Okay, remember if I using to find let's say because they have minus 1, right? The difference of n minus 1 over n. If I using n the 2, okay, not this one, not, and then how about 2n minus 1 over n square? How, if you curious how I get this one, you should think by yourself, or you need to work because this is already set in mind. And then let me put to be here. If this is the first term, second term, and then the third term. The first 2 times 1 minus 1 over 1 square. 1 square 1. Okay, this one is correct. How about the second term? The second term is, the result will be 3 over 4. 2 times 2 minus 1, 2 square. So it's 3 over 4. How about the 3 terms? So 2 times 3 minus 1 over 2, 3 square. 2, 3 minus 1, 3 square, right? So it's 5 over 9. Okay. So from here, we get the conclusion if the formula is 2 times 1 minus 1 over 1 square plus 2 times 2 minus 1, 2 power square, and then plus 3 minus 1 over 3 square. Look at the formula. They have the same in this one, and 2 and 2, 3 and 3 until what they are? They are until 9. Okay. So 2 times 4 minus 1 over 4 square plus 2 times 5 minus 1 over 5 square. So from here, we know that the sum notation is E starting from 1 until 1, 2, 3, 4, 5 until 5, and then the general term is 2 times E minus 1 over E square, everyone. I hope you understand what I'm explaining. Properties of sum notation. Is C element of real number and P, R, N element of natural number. But remember everyone, C, P, R, N, it's just the symbol. So you can using another alphabet if you want. But to be honest, what the most thing you should remember is if the E, if the I, and N, it should be always element of natural number. That's it. Okay. So from here, the first properties, if the general term just C, which is the constant, so the result will be C times N. How about if the C having a general term, so we can put the C in the front of the sum notation. How about the number 3? So if we have the sum notation between two general term, which is which is AE and BE, so you can make it, they are easier. You can divide them, but you need to put their sum notation each other, everyone. How about the number 4? The number 4 is most carefully, everyone. Okay, let's say in the number 4, you have the sum notation E equal 1 until N AE, and then you want to, and you want to separate separate the both of them to be, you can write about another symbol, like this one is N, so we put the P, so E until E equal 1 until P, AE plus minus sigma. Remember, when you put the P, and then in here they are changed to E equal P plus 1 until N, AE. But remember, where P less than N. The number 4, like the same problem, the same properties, these properties, if the, like I said before, starting point is not only 1, everyone. Starting point is, they can start with that wherever they want, right? But in here, let's say E equal P. Let's say P, I took 100 until the end, AE. So sigma, so you can change the starting point which if you commonly the starting point they are 1, but some question they are starting with like 100. So if you get the 100, you can change that starting point with, you can subtraction with the both of them between lower and then the upper. If you subtract the lower with 99, so you need to subtract to the upper with the 99. How about the general? In the general, they are reversed. If you from the starting point they have subtract, but in the general term they need to, yes, addition, but the same value. Like 99, yeah. How about the P is minus? You want to change to be the positive. So it's the same. So if let's say minus 1, but you want to change to be 1, so you need to adding plus 2. You adding plus 2 in the upper, you need to adding plus 2 in the lower, the upper, same. But in the general term, you need to make the subtraction, everyone. How about this one? Okay, like I said before, E starting point, but there's the symbol. You can change the E wherever you want of the variables. So in here, if there E equal 1 until N, the general term AE, is it the same? Still the same with the G equal 1 at until they have the same N until AG. Or they are using another variable as long as they have starting point with the 1 and then they have the end point with the M is still the same. So without further ado, so let's jump to the example. Given that sigma with the E equal 1 until 10 with the AE equal 30 and sigma E equal 1 until 10 BE equal 40, evaluate the following. Sigma E equal 1 until 10, the general is 2AE plus 5. Okay, so from here, we can using the properties number 3, right? So we can divide them to be E equal 1 until 10, 2AE plus sigma E and equal 1 until 10, 5. Okay, so from here to AE, so we can using the properties number 2, this one is equal with the 2 sigma E equal 1 until 10 with the AE plus, okay, this is just constant, everyone. So remember, the constant is from the properties number 1, unit times the constant with the upper limit times by tens. Okay, so from here, we know that sigma, this one, they are given us in the equation. So this one is the value is 30, right? So 2 times 30 plus 50. So 50, so this one is 100 tens, everyone. Okay, now the second is sigma j equal 1 until 10 for a g minus 2 bg minus 3. So in here, from here, we can using the properties to be sigma j equal 1 until 10 for a g minus sigma j equal 1 10 2bg minus sigma equal 1 10 3. So from here we can using the second the second property. So 4 equal j equal 1 times ag, and then this is the same with the second properties to 2 equal j minus 1 10 bg minus. So from here, because there are constant, so we can write to be 3 times 10, everyone, right? So from here, we know that from the last properties number 6, we know that if sigma E equal 1 and AE is the same with the sigma j equal 1 and aj, everyone. So from here we have the j equal 1 until 10 ag. This one is equal with this one 13. So 4 times 13 minus 2 times j equal 1 until 10 bag. So this one is 40 minus 30. So from here 120 minus 80 minus 30, right? 120 minus 80, 40, 40 minus 30 is 10. So this is, you can use application that properties that we have, everyone. Write each of the following sigma notation by changing the lower index into 3. So from here, the purpose, they want to change the lower index, which is the E, or which is the I in English, yeah. And then, so from here, we can using the properties. They want to changing the index to 3, so we can write to be E equal 1 plus 2 because the total is 3, and then the upper index 10 plus 2. Why plus 2? Because they have the same adding plus 2. How about the general? The general is we can using the properties number 5. If they are in here plus, so the E is changing to be, yes, correct, is minus 2, E minus 2, right? Okay, plus 4. Okay, the changing just the variable, everyone, not the constant. So from here, we can write to be E equal 3. This is 12. So this is to be 2e minus 4 plus 4. Okay, so from here we can cancel minus 4 plus 4. So the sigma, it's equal with, yes, index, the lower index is equal 3, and then the upper 12, then the general term is 2e, everyone. The equation still the same. You need to changing the lower index to 3. Okay, so from here we have the e equal 5. Sorry, we have e equal 5 until the upper limit is 10 with the general is square minus 2e. So from here we need to change the upper limit, lower limit to be 3. So e equal 5 minus 2 because we want to 3. So in here 10 minus 2. How about the inside of the general? So we need to change each of them I to be, yes, if in here minus, so in here is positive. I plus 2 square minus 2 times e plus 2. So from here we need to fix to be e equal 3. So it's equal 8. So e square plus 4e plus 4 minus 2e minus 4. So from here we can cancel 4 and then 4. And then the result will be sigma e equal 3, 8 e square plus 2e, everyone. So this is the transform from the index, lower index e equal 5 to be e equal 3. If sigma e equal 1 power index, upper index, and 5e minus 3 equal to 5, you need to find the value of n. So from here, we can still using the properties. Okay, remember, sigma e equal 1 upperly index is n, 5e minus 3 equal to 5. So from here, we can using the second properties to be sigma e equal 1 and 5e minus sigma e equal 1 and 3 equal to 5. And then this one equal with 5 times by sigma e equal 1 power n. Sorry, bukan 5, but in here is I. So it's I minus. Remember, this is the properties number 1. So you need to times by the constant with the upper index 3n minus 2, 4, 5. Okay, everyone. So we need to find what is the sigma E 1 power n E. Okay, remember, sigma E equal 1 and E is the same with the first term plus second term plus dot 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 until the general term, right? So in here is still the same. So you can make the series to be the 1 because starting 1, and then if they change 2 plus 3 plus dot dot the until n. So sigma is that the meaning you need to sum of the value. Remember, because they have the difference is 1, so you can using, yes, sum of the difference or arithmetic series, everyone. Arithmetic series is from the definition is Sn equal the first term plus the nth term divided by 2 times by n. The first term is 1. The general term is n because we don't know how much is it, and over 2 times n. So this one is equal with n plus 1 over 2. So we need to change in here 5 and n plus 1 over 2 minus 3n equal with 2, 4, 5. Okay, so from here we can wait a minute, this is a problem. Okay, so from here we can write to be n squared 5 n squared plus 5n minus 6n over 2 equal with 2, 4, 5, right? So from here 5n squared minus n minus 490 equals 0. I move this space. So from here you need to factorize them. Okay, so 5n is n equals 0. So the factorize is this one is let me write 49, and then this one is minus 10. 5n squared minus 50, well, okay, so n is equal with minus 49 over 5 and n equal 10. So remember, n always member of the natural number, so the possible result is n equal 10, everyone. I hope you understand. Okay, now we move to the some important formulas. So from here, we know that from the previous example, if we want to know what the sigma E equal 1 until n the E, we need to find using arithmetic series or geometric series. But in here, some important formula, they are already give us what's the formula of them, of the some important formula. So if the sigma just E, so n plus 1 over 2. How about if they are square? So the square is n plus 1 to n plus 1 over 6. How about E power 3? E power 3 is n times n plus 1 over 2 powers 2. How about if they are 2, 4, 6 plus dot 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 until 2n, so the sigma is 2e, so the formula is n times by n plus 1. How about they are the general term n dot n plus 1 or e times e plus 1, so the general is the sum, I mean, n plus 1, n plus 2 over 3, or the last is the last is sigma E equal 1 power n 1 over E times E plus 1 equal with n plus 1. So if you're curious about this one, this is, I'm not talking about you need to remember. No, if you can find by yourself, it's good, everyone. But if you just want to remember, this one, it doesn't matter. But for me, for easier, you need to know where they get from. Okay, because we will talking about some important formula to proving in the math induction for the next meeting, everyone. So without further ado, so let's jump to the another example. Calculate the following terms. Okay, in this example, we have e equal 1 until 18e. But we can using the first with the manual way and then the second with the some important formula. So from here, from the manual way, we know that the starting point 1 for e, so we can write to be 1 plus 2 plus dot 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 until 18, right? So from here, we can see there have different ones. So we can using the arithmetic series. Arithmetic series from the definition is the first term plus the nth term over 2 times by n. The first term is 1 plus the nth term is 18 over 2 times the n is the total until the upper index is 18. So 18, 9. So it's equal 19 times 9 is equal 171. Okay, how about the some important formula from here we can write, remember, e equal 1, 18e, this one is equal with the n plus 1 over 2. What's the n? N is 18, 18 plus 1 over 2, 9. So 9 times 19 equal 179. Okay, the result are the same. So it's depend on you what you want to using formula, everyone. Calculate this sum notation. Okay, so from here we using the sum important formula. So this one is equal with, but you need to using properties too to be sigma e equal 1, 11 to e minus 1. Is this one it's equal meaning with sigma e equal 1, 11 to e minus sigma e equal 1, 11, 1. So from here, from the properties or from the, what's the name? Let's see, I just remember the one. Let's say I just remember the one, some important formula. So 2 e1 11 I, sorry, this is not equal but minus 1 times 11. So from here we can write 2 open bracket and n plus 1 over 2 minus 11. So from here, we can cancel 2. And then what's the n? N is 11. 11 plus 1 minus 11. So 11 times 12 minus 11. So this one is equal with 11, 121. Okay, everyone, now this time of exercise. The question 1, expand the following summation. So you just need to work with the circle. Okay, OS, official statement. You need to answer with the circle. But it doesn't matter if you working with the all of the question. But for me, the circle is the importance. Okay, this one is 1, 2, 3, 4. And then given this one, you need to evaluate the B, and then the C, and then the here, and then the last in here. So everyone, thank you for today. I hope you understand what I'm explaining. Assalamualaikum warahmatullahi wabarakatuh.